and we can move that throttle up to max power.
50,000 horsepower, that's massive. Today we're going to take a look inside the Rolls-Royce engine factory. Every 20 days a new engine gets produced.
So today we're going to look at engine build for a XWB engine, which is the exclusive engine on the A350. Fan blades, fan disc, and over on the table here are the annulus fillers. Now they're the pieces that go between the blades to make a nice smooth finish for the air flowing into the engine. So what we've got here now is we brought the disc, the blades and the annulus fillers together and formed the fan that goes at the front of the engine. Just go careful, Sam, the leading edges are pretty sharp. That's to get a really efficient flow into the engine. Now what this is what drives the fan or the compressor round. So you tend to see turbine blades hidden in this casing up here, and then a long shaft that goes through the middle of the engine and drives the compressor or the fan at the front. And if you look behind me here, you can see the core's been flipped to be from vertical to being horizontal, and the big fan case has been put on the front.
22 giant fan blade is the turbine blade inside. They can generate each of them 800 horsepower. So together, 68 turbine blade generate over 50,000 horsepower. That's massive.
Just 20 days from start to finish, and the engine's ready to go across the test before it goes to our customer.
Welcome to 58-bed control room. Here is where the guys take control of the engine. We take the engine, we rig it to the test facility, and we carry out the customer's requirements, either to test it for maturity, for different strains, pressures, temperatures. We can do many things here in Derby in the test bed. This is the test cell now. So when we go through this door, we'll go into the test cell and we'll be able to look at the test facility.
Wow.
This is where we do different types of testing. We pour loads of water down the front of the engine to simulate a storm and flying through a storm and show that the engine performs correctly in that. We can do bird strike testing, where we fire birds at the engine to simulate what could happen if you were to hit a bird and show that the engine's strong enough to take that. And we can also do what we call cold start testing, where we basically bring a massive fridge in and put the engine in it.
Make it really cold.
Overnight, make it really, really cold, and then take the fridge away and prove that we can start it cold. Because engines find it more difficult to start in really cold conditions. So all kinds of really important testing that we can do on this cell in Derby. Now every engine that we build here in Derby will come through here before it gets delivered to our customer.
So this is actually a test engine for our latest carbon titanium fan and containment system, which is the application of carbon technology to reduce the weight of the front of the engine, the fan and the fan case. Now we've got a technology where, because of the 3D weave of the carbon fibre, we can make a blade that is both lightweight and aerodynamically efficient. So a system like this would save about £750 per engine. What we've got to prove as the engine manufacturer is that the engine doesn't necessarily have to continue running and producing thrust, but it does have to make sure that it runs down safely and no high energy debris penetrates the casing. So if one of this were to happen while you're flying, then you might spill your gin and tonic, but you'd be perfectly safe.
We're here today at Bed 80, so once it's finished, this will be the world's largest indoor test bed for experimental testing. So this is where we'll actually push our engines to their ultimate limits so we can understand how they really perform. So really exciting for us. It's not just a construction project, you know, this is about testing for the future for Rolls-Royce. This is where we put the engine on a pylon, so effectively we make the engine think it's fitted to an aircraft. And what we're doing here is the air's coming down, it's hitting that cone, but what that cone's then doing is it's spreading the air out throughout this space. This test bed, you know, build a test bed like this probably every 10 to 15 years. So from an engineer's point of view, this really is a once-in-a-lifetime opportunity.
And their legacy will last for a lifetime.
That's it,
many,
absolutely.
Many more years to come
yeah.
with such an engineering feat like this.
Yeah, absolutely.